All right, here we are at 5:47 a.m. You know, it makes a lot of sense to actually do this part first. So let's go ahead and do it. We're supposed to compose the function anyways. We've got a 4, then we've encountered 3 over x. Oops. Minus 7. And then minus 5. So if you look at this ugly thing, I can tell you right there that x can't be 0. Because if x was 0, this thing would never exist. It's going to change colors on me. And we're going to go ahead and clean this up just a little bit. Distribute this 4. 1 over 12 over x. 4 times the negative 7 is negative 28. We have to take away this 5. It's negative 33. Minus 33. We're going to clean the fraction up now. Unified fraction. So we're just going to x everything. It's the LCD method. The denominator is x. We get x over 12 minus 33x. All right, now we're going to invoke this rule. 1 over anything. The anything cannot be 0. It's 12 minus 33x cannot be 0. By the way, this is the answer to part 2. We're going to just move that on over. 12 is not going to be 33x. Therefore, x is not going to be 12/33. So here's my domain. All values of x such that x is not 0 or 12/33. All right, moving on to 15. And by the way, we've also done both parts now. All right, 14, restrict the domain so that f of x is 1 to 1 and find the inverse of g of x equals, I guess this should be written g of x. So g of x is 1 to 1. So if you think about a quick graph of that thing, it goes right 3 and up 1. And it looks like that. We're just going to throw this away. X is greater than or equal to 3. We're talking about my domain. I am bracket 3 to infinity. Can't write this one, can I? Now we're going to go through the process of writing an inverse. We're going to swap x and y. We can get the g out of that. That'll become x becomes a y. And we're going to play the isolation game because we want to isolate this right there. So we're going to subtract 1, perhaps. Next move would be to divide out this 9. The next move would be to counteract the square root symbol. So we'll make the square roots of both sides. Square root of 9 is 3. We have root x minus 1, and we freed up y minus 3. We're just going to add 3 to both sides. So root of x minus 1 over 3, add 3 is the inverse of... That's apparently too early for me. It's not called f of x, it's called g of x. Is the inverse of g of x. All right. Moving backwards. Function is even and has y-axis symmetry if f of negative x is equal to f of x. Function is odd and symmetrical about the origin if f of x equals f of negative x. Determine whether g of x equals 2x to the fourth minus 4x squared plus 3 is even, odd, or neither. This one will be an even function. We're going to plug in a negative x. Notice how I do it. It's the correct way of doing it. If you take a negative and raise it to an even power, you get a positive, or you get a positive back. We don't distribute here. We square first. And you can tell that g of negative x is equal to the original thing. This thing is definitely even. I don't have to do the next step, but I'm going to because some of y'all don't quite know how to do it. G of negative x would be to take g of x and wrap it in a negative. invoke the distributive property. And you can tell that what they're saying here does not line up. These two do not match. Sometimes they do, but this is not odd because this isn't true. So it's got to be choice A. I don't know why I circled that earlier, but it's choice A, it's even, because when you plug in negative x, you get the original function back. Moving backwards again to 12, identify all asymptotes of this function. All right, so the easy ones happen in the denominator. Your vertical asymptotes, they happen when the denominator is equal to 0. So you take x squared minus 16, you set it equal to 0. You add 16, and x is plus or minus 4. Choices 1 and 4. Your horizontal asymptotes, your slants asymptotes, and all other asymptotes, you do long division. So we're dividing by x squared minus 16, and we're seeing if we can enter 4x squared minus 3x plus 2. And of course, there are shortcuts to this stuff. But to turn an x squared into 4x squared, you multiply by a 4, and you get 4x squared minus 64. You wrap before you subtract. This guy gets carried down, and then we get plus 66. This is a remainder because you cannot turn x squared into an x with positive exponents. So this is the last asymptote. And there's a horizontal asymptote. It's not a slant, it's a horizontal. Find the difference quotient. Not a hard skill. About 3 of you in this room can do it, maybe 4. Daniel Richardson, figure it out. It's not hard if you watch the video, because you don't study. What you don't realize is when you do things like that, you're making it my problem. We're going to do this piece first. X plus h squared happens when you write it twice in your FOIL. You get x squared plus xh plus xh plus h squared, which is x squared plus 2xh plus h squared. There's a 5 out front that you still got to worry about. Don't forget about it. Don't forget about the distributive property. (5x squared plus 10xh plus 5h squared minus 2x minus 2h plus 1. And let's do the rest of it. Minus the original function, f of x, 5x squared minus 2x plus 1. Now, whatever is in this set of parentheses cancels with something that's not. Whole thing is sitting pretty over an h. What do we have? We have 10xh plus 5h squared minus 2h all over an h. And each of these 4 pieces contains an h, so we reduce. We're going to put this 5h last. There's your answer. It didn't take long to do. And there are shortcuts to this too. Let's see, 10, find the domain of the natural log of 4x minus 2. So if we get to this week, I don't know, but for a logarithm with an argument, the argument is bigger than 0. So 4x minus 12 is greater than 0. 4x is greater than 12. X is greater than 3. So I can either do a set builder notation, all values of x such that x is greater than 3, or I can do interval notation, 3 to infinity. Pick your poison. Moving forward to 9. You know that for 1 over something, the something cannot be 0. So x squared minus 5x plus 6 is not 0. This one's not as easy as the last couple have been, but it's really not that hard. You just have to factor factors of 6. A positive 6 would be negative 2 and negative 3. And negative 2 and negative 3 add to negative 5. So I know that x cannot be 2, and x cannot be 3. There's only about 3 or 4 of you that haven't quite figured out number 9. That's super easy. And this is probably going to be the last time number 8 sticks around. The quadratic has a vertex at 4, -3. Determine the vertex quadratic after transformation's been performed. We have beat this to death. This is a left 5, and this is a down 3. So if I go left 5, I'm taking away 5. And if I go down 3, I'm taking away 3. So 4 minus 5 is -9. And -3 minus 3 is -6. Count left. All right, number 7, one of the tougher ones. So be thinking about your general transformation rule. Which I wrote down wrong. It's AS of x minus h plus k. And the first thing we're going to do is this guy first. All right, it's that guy first. So stuff has happened. We have actually gone, what, left 4? We went from 2 to -2. So what's happened is we've added 4 to the inside. This guy is second. Here A is 1. And here A is -2. So we take the function and we wrap it in -2. Now, something else has happened though. All right. Because let's write the function. What is f of x? F of x is x minus 2 quantity squared plus 3. Now, I went supposed to add 4 to the interior. That becomes x plus 2 squared plus 3. And if I wrap that in a -2, and you got to wrap the whole thing just like I did here. I wrap the function f. I get -2 x plus 2 squared minus 6. And this thing is not down 6 units, it's down 5. So I need to add 1 back. And that's how you do it. Just add 1 back. All right. Moving backwards to 5, determine the intervals on which this thing is negative. So let's just do a little factoring. Factors of 6 are what? 3 and 2. That'll work. Minus plus, because the outside is -19, the inside is +2. So x is -2/7 and x is 3, and I'm looking for negativity here. This was 7x squared, which will, anyways, our zeros are at -2/7 and 3. Since it's 7x squared, which is positive, it's going to open up. Your negative space is this stuff right here. Its left boundary is -2/7 and its right boundary is 3. See, it's not too hard. It's got a factor. You'll notice that the front of this has changed quite a bit. I dropped some stuff off because some of it just had to die. It was time for it to die. Anyways, we have a factoring problem. We're going to focus on the first 2 terms. I can pull a 2x and I'll be left with x squared minus 16. And the x squared minus 16 ought to repeat. So what do I pull from x squared, 7x squared to become x squared? I pull a 7, and it was positive at that. The common factor is x squared minus 16, and the stuff that's left over is 2x plus 7. X squared minus 16 factors is x minus 4 times x plus 4. And there you go. There's the full factorization of that polynomial. Evaluate 1/27th to the -4/3. The negative exponent means you can flip the fraction and make it 27 4/3. So that's what that gets rid of the negativity. This is asking me to take the cubic root of 27 and then raise it to the 4th power. The cubic root of 27 is 3, and 3 to the 4th is 81. In words, what is log base 3 of 81 asking? So log base B argument A. Log base B argument A by default says what power of B creates A. All right. So if I look at my numbers here, it's what power, if I can spell what, of 3 equals 81. There's my words. All right. And the answer to that is 4. Just like it was up here. The answer is 4. All right, last one. Find the solutions of the absolute value of -3x less than or equal to 12. That is a free response problem. And write two equations. -3x plus 5 is less than or equal to 12, or 3x minus 5 is less than or equal to 12. So we take away 5, we get 7. We divide by the negativity. When you divide by a negative, an inequality symbol flips. X is greater than or equal to -7/3. And over here, we add 5, less than or equal to 17. And we don't have negativity on this one. There's your two answers. Think about what that looks like on a number line. Let's see, 17 over 3 is what, close to 5? A little over 5. So I'm supposed to be greater than or equal to -7/3, but at the same time less than that. Therefore, my answer is the space between these two things. I can write it like that, or I can use set builder notation, all values of x such that -7/3 less than or equal to x less than or equal to 17/3. Pick your poison on how you write. There you go. There's your twin. I hope you guys do well on it.